Assalamu alaikum. This is the manual calculations for question 1. We have to find the v of t and I of t for three cases: underdamped, overdamped, and critically damped. So we got the Vs equal to 40 volts, and we got R equal to 10 ohms, and inductor is 0.5 H. So we have to get ourselves R and C to get the three cases. So for the underdamped, alpha should be less than omega, and for overdamped, alpha should be more than omega, and for the critically damped, the alpha and omega should have the same value. So we fix the value of omega to 200 radian per second, and then actually in this circuit, after the switch is on, after the switch is off, because when t equals 0 the switch turn off, so we will get a series circuit, not a parallel circuit. So this is the equation for the series circuit. From this equation we get the value of C. The capacitor was 50 microfarad. So we just fix the value of C and L, then we go to vary the value of R. So since L equal to 0.5, when we multiply it by 2, we will have 1, so omega equal to R in every single time. So for the overdamped, we use omega as 200 fixed value and alpha 400. That's mean our resistance is going to be 400 ohms. Okay, for t less than 0, we are going to calculate the VC and the IL, the initial condition. So we got IL equal to 4 amps and VC equal to 0 volts, since the inductor, when it's fully charged, is going to be short circuit, so no more current will follow through this resistor and this capacitor. So we just calculated the current for the capacitor after t equals 0 or more than 0, so it's going to be 4 amps. So dV over dt is going to be 80,000 volt per second, and for the di over dt is going to be 0, since there is no voltage in the capacitor, so there will be no voltage in the inductor. So now we should calculate this one S2. Those are the values. So this is the overdamped case, so this is the equation for it, and then we get the V of t equal to 150.47 epsilon negative 53.59 t minus 115.47 e to the power minus 746.41 t. So, and the same thing for the IT. This is the equation. We just got the value of A1 and A2. So this is the equation for V of t for the overdamped case. So for case 2, which is the critically damped, so omega should equal to alpha. So we set R is 200 ohms, so omega will be equal to alpha, which is equal to 200. So we again calculate S1 and S2, then we write the general solution for the V of t when it's critically damped. So this is the final answer for V of t. and then the same thing for I of t. Just write the general equation, then find the value of a1 and a2. So this is the final equation for I of t. And the third one, it's the underdamped case. So R will be equal to 100, so omega will be more than alpha. So in this case we are going to calculate omega d. So then this is the general solution for v of t, which then we have to get the value of b1 and b2. First we apply t as 0, since we have b0 equal to 0, so the value of b1 equal to 0. Then we get the first derivative of this equation, and then again replace t with 0, since we have v of t dv over dt, I mean dv over dt when t equal to 0 equal to 80,000. So this is the value of b2. This is the equation for v of t. Then the same thing for I of t. Write the general solution, get the value of I1 and I2, replace t with 0, differentiate it, and again replace t with 0, then we get the value of b1 and b2. So this is the general solution for I of t when it's underdamped. So this is the three equations, I mean the 6 equations, 2 for every single case. Now I'm going to move on to the simulation. So we just start with the overdamped case. Actually LT spice, we used LT spice to simulate our circuit, so it doesn't have a switch, a normal switch. So this is a switch which is going to turn off or on due to the voltage supplied to it. So we got this voltage source, have value of 1 volt for 10 seconds. So the inductor and the capacitor will be fully charged. Then it's going to turn off, so the switch will act as an open circuit. So for the simulation we got the value after t equal to 10 seconds, so it will appear as it's 0 seconds. Then it's going to show only for 100 milliseconds, so it's enough to get the values, or to get the signal, I mean. So this is the value of VC. This is the voltage in the capacitor in the red color, and this is the value of the current in the inductor, which in the red color. So for the CIRCUITE damped, the same thing, the same switch. This is the volt in the capacitor, and this is the current in the inductor. The current is the green color, and the voltage is the blue color. So this is the last case, the underdamped case, R equal to 100. So this is the voltage, and this is the current in the inductor. The voltage now take the green color, and the inductor current take the red color. So if we want to combine all of them together, just we press them. So we have to make this minus, so we can just change the colors for the voltage, the colors that near to green. And for the current, choose the red colors, so it's easy for us to differentiate between them. So this is it. We can open it as a full screen. So this this is the the voltage which is increased firstly. I mean it's increased quicker than the rest, which is the voltage in node 14. We are going to see which case is this one. And you see this is it in the under dump case. It's the first voltage increase faster than the rest. That's it.
Assalamu alaikum. My name is Mohammed Ahmed Saeed, and I will continue to the question 2. It is simulation and manual calculation. First thing first, we will do the manual calculation. Here we choose for our L1 will be 0.12 Hertz and L2 will be 0.6 Hertz and C1 will be 0.015 volts farad and C2 will be 0.03 farad and IO current current given will be 20 angle minus 45. When we calculate into imaginary values, we found our C1 or capacitor 1 minus Ch2 and capacitor 2, our Z2 minus Ch1 and ZL1 will be Ch4 and ZL2 will be Ch2. Then we will analyze our circuit. We do the left part. We will analyze the left part. We will simplify it and make 20 resistance to capacitor 1 minus Ch2. It is a series, so we make it parallel to Ch4. Then we calculate it and we find Z equals 4 ohm. Then our current will look like this: Z Vs. Then we will do nodal analysis. And the KCL, which equation is current in equals current out. Our I1 which is minus Vs, our I1 equals to I2 plus I3. So we have our I3, we have already our I3, then we can find the phi, that node, a phi node. Then our phi node will equal to Ohm's law, I times R. Then we find our phi, which is minus Ch2 28.28, and then we will find we will do another analysis, which is ion current I1, which is minus Vs minus V divided by 4 and equal to V divided by Ch2 plus 20 angle minus 45. When we calculate it, we find our Vs, which is 84.85, and angle round it will be angle 90, positive sign. Then we will do the simulation, and here our simulation. As we mentioned in a report and in the manual calculation, we we take a C1 or current capacitor 1 0.015 and capacitor 2 0.02, inductor 1 0.12 and inductors 2 0.06 and current I1 equals 2 ohm and current I2 will be 1 ohm. Then we will find our P source will be the voltage that we calculated. Then let us run. When we run it, then we need to verify the current that is given IO should be equal to 20 as it is amplitude equal to 20. Yes, here it is, and the amplitude will equal to 20. And if we, as we mentioned it in the report, if we calculated the IO, the current is given, it is 20 times sine 33.33 t, and t will be equal to 1. So if we multiply t equal to 1 and convert the minus 45 angle into radian, we will find that value plus 18. So our current will be verified. Thank you.